Well, hi there. Thanks for showing up for your learning. I got some questions from some of your classmates, or maybe from you, and I was really excited because I love getting your questions because I love teaching this stuff. Let's take a look at how you can solve this situation where Dhruv invests $500 in an investment. He knows his money's going to double every 7 years. That's about 10% interest. Okay, and he wants to know how long is it going to take to have $1 million. All right. So there's really, I see three good ways to solve this problem, and then one way that the juries sell out using AI. Okay. So I'm going to show you how graphs, tables, and equations can all work together to structure your math knowledge and build your understanding of these types of exponential functions. And you can use this for any functions. Functions can all be represented in tables of values, graphs, of course, and equations. All right. So let's start by building an equation. We might go ahead and Google and say, I want a doubling equation, something that's going to double something at a regular interval. And then you'd find this. The amount of something is a function of time, and it's equal to the initial amount, and it's going to double every t divided by the doubling time. So we'll call that like h. We'll sometimes see half-life there, so that's why I chose h, where h is the amount of time it takes to double. Now let's build our formula here for Dhruv. He knows that he's going to have an amount of money, which is a function of time, and it's going to take his initial $500 and double it every t years. No, every 7 t years. Every time 7 years goes by, this exponent will go up by 1, right? And his money will double. Okay, now, so that's an equation. We could go ahead and throw that equation into Desmos and get a graph-based solution. And here's what our solution is going to look like, okay? There's going to be the y-axis. No surprises there. There's going to be the x-axis. And here's what you're going to have. You're going to have a as the initial value. So this is going to be, 500 down here, $500. Right? That's what he invests initially. That's at 0 years. And then maybe like here, 10 years, 20 years, 30 years. I happen to know the solution, so 40 years. Don't be too impressed by me just doing this in my head or something. 50 years, 60, 70. Okay. And if this was $1 million up here, this question is basically saying, when will our graph pass that y value? Well, we know this is growing exponentially. So it's going to look something like this, right? Something like that. And when you find that there, that's a point. There's one point along the graph. It's one combination of an amount of time and an amount of money that he will have at that time. That's your solution. So that's how you use a graph to do it. So you just dump your equation into Desmos and then graph the line y equals 1 million and find the intersection. Very easy. Very easy. And it also builds your understanding of the situation because you're seeing the graph, go up, you're seeing it cross that point, and oh, that's where it meets the point. So it structures your understanding, helps you visualize in the future. So it's a good method. And now, if we want to solve this just with an equation, let's see what simplification steps we have available. Oh, before we go on, we could also do a table of values, and it might look like this. Okay, you might even do this without an equation. Like a grade 9 can work on this problem. They can say, well, after 0 years, he's going to have $500. Oh, these are my values of time, and these are my values of money. Okay, 0 years, he's got $500. 7 years, he's got 1,000. 14 years, 2,000. Just double it every 7 years. 21, 4,000. And you're going to go dot, dot, dot until you get to 70, and it's been doubled 10 times. Okay. And so after doubling 10 times, well, let's just quickly figure out what that would be. Well, 2 to the 10 is 1,024. So you go in here, you go like, okay, well, after it's been doubled 10 times, that's 2 raised to the power 10 equals 1,024 times 500. Well, that's going to be like, yes, this number, 5,000. Oh, we're getting very, very close. It only needs to double one more time, right? So if I double that one more time, like 77 years here, cross my sevens because I want that habit, then it's going to be more than we need. So now what I can do is start guess and checking. This is going to be 1,024,000, right? So very, very close. It's going to be like 76 years or something. Okay. And then we guess and check. But I'll show you a little better way you can refine your guess and checking. Okay. So now let's go back to this equation-based solution. And notice I'm just naturally popping between the different solution methods because to me, they're different ways of understanding this problem and thinking about it in different ways. So to solve this, one thing we could do is just write it out. 1 million is the value of A of t that I want. And so that's going to be equal to 500. It's going to be equal to the function, right? Multiplied by 2, raised to some power of t that I don't know yet, divided by 7. And then I might take my photomath phone. This is my old phone, and it pretty much only has photomath on it. And I use it to say, that student is writing things down in a very precise and yet not the way I taught it way. Let me see if it's it is photomath. Okay, so your math teachers aren't really, really dumb. So we notice these things. We're also really, really good at math. So when you suddenly become really good at math, but in a way that you haven't been taught, we're like, I'm suspicious. Anyway, that's not to say photomath is not good, but let me talk about the problems with photomath for this problem. I photomath this problem, and then the solution looks like this. I see lots of logs in there. Log, 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 log. It's like a really long solution, and it involves logarithms. Maybe a word you don't know yet. Okay, a logarithmic function is the inverse of an exponential function. You will learn about those in grade 12. You have not learned about them yet, unless you went ahead and looked at a YouTube video, how do I solve exponential functions? Okay, then it will show you. Okay, and so there are reasonable ways to learn it. So the useful way to use photomath is to say, I don't understand this question. Let's see how photomath does it. Oh, I can understand what photomath is doing. I see the part I was missing. I can use it to teach myself and fill in my learning gaps. Awesome. Great use of AI to support your learning. Okay. If you just copy out the solution line by line here, but you don't understand any bit of it, you're a bit like one of the random monkeys randomly typing Shakespeare. We don't hold you up and say, wow, you're amazing. You haven't really done anything particularly useful. So anyway, let's see, how would we solve this? Well, solving any equation, you want to isolate your variable as much as possible. So let's first start by getting out our inverse operation pen, moving my face, get out the inverse operation pen and divide both equations by 500. That's a move that we can do, right? 1 million divided by 500 is going to be 2,000. So we go back, get our old pen out. 2,000, we want to know when is 2,000 equal to the power t over 7. All right. Now here, actually, we have a little shortcut we could do, which would be knowing our powers of 7 and knowing that 2,048 is very close to 2,000. So our value of t will be just a little bit lower than what we need to do that. If we want to simplify this even more, what we could do is say, well, I can write 2 to the t over 7 as, well, this is still 2,000, is equal to 2 to the 1/7 to the t. And then I can sort of consolidate that 2 to the 1 over 7. Okay, so then I go ahead and find the 2 raised to the power 1 divided by 7 equals, no, that's not correct. 2 raised to the power, always put these in brackets, 1 divided by 7, and the bracket. So see, I had to put the exponent up there in brackets for it to do it correctly. And then, so that's 1.1040. Remember I told you this is about 10% interest per year? Did I tell you that? I might have done that in the first take of this video. Doubling your money every 7 years is roughly equivalent to 10% interest per year. So that's the growth rate per year. We could use 10.4 as our growth rate, or 10.41 if we want to be even a little more precise. And then we can write this as, so we're going to do 10.4. 2,000 is going to be equal to 1.104 raised to the power time. That's 10.4% interest. It's a cute chipmunk outside my window. Now, I can use this now to guess and check. Okay? And so now I'm back to using a table-based solution, but what I've done is I've isolated the variable as much as I can. Okay? If I point photomath at this, it's going to go logarithms. It's going to give me a logarithm-based solution. I'm not presenting that in this video because I want to leave some tricks for you to learn in grade 12. So now we guess and check with this. So we build a table-based solution. And it looks like this. Pion, pion. Okay, so we have different values of t, and we have 1.104 raised to the power t, and our target is 2,000. Okay, we want to 2,000 times our Drew's money. So we've already know that it's got to be more than 70 years and less than 77. So let's guess 76. Okay, we've already done some good work here with the graph and with our table over there. So let's use that to guide our guess and checking. So here's what we do. So we're going to, actually I can work with this exact number by just putting it in the memory of my calculator. And then I'm going to raise that to the power 76 equals, oh, it's a little shy. It's a little small, okay? So that's 180 something something. So I need to go bigger. So let's go 76.5. Okay, so we're going to clear, going to memory recall, raise that to the 76.5 equals, we're closer, it's about 1950. So we still just need to nudge that number up a little bit more. So let's go clear, and we're going to go memory recall, and then raise that to the power 76.7. Very, very close. Clear. Memory recall. Raised to the power 76.78. A little heavy. 76.78 was a little heavy. So I write them in a table so I can organize them. That's about 2003. Let's see if we can get even closer. 76.77. Let's try. Clear. Memory recall. Raised to the power 76.77. That's $2 heavy. Okay. 76 point, not $2, 2 times, it's actually $1,000 heavy. So that's 2002. So I saw I lost $1 there. So by losing 100th of a year, so let's lose 2 more hundredths of a year. 76.75. Let's try that. Just like trying to guess and check somewhat intelligently. Memory recall raised to the point 76.75 equals, oh, that's way low. 76.75 was, well, not way low, 1998. Yeah, 1998. So let's try 76.76. That's cool. Memory recall raised to the power 76.76. This is how donkeys do math. They guess in Shrek. Okay, equals. Hooray! You want to get it closer? 76.765. Memory recall raised to the power 76.765 equals. Okay, we're a little heavy now. Okay, so clear. Memory recall raised to the power 76.763. 76.762 looks like. There. Oh, I cleared the memory. Anyway, you got the idea. Okay, you got the idea. Now, in Desmos, I've already graphed this. Watch, but if I put this in, notice this is not a function. This is like saying, find me the value of x. Desmos can just spit it out for you. There it is there. And you can zoom in on it, and you'll find it at 76 point. 0.7, 0.75, 76.76, 76.7605. Okay, there, that's really close and accurate. Oops. So that's another thing you can do is just dump that in. But let me show you what I prefer. Write this in as like a function. A of x is equal to this. So it's a function of the amount is a function of time. We're going to change the, we definitely want to see like the starting value, and we want to see y values up to 1 million. There. And we need to see, let's just see 80 years there. Boop. 90 years. There. All right. So now, if we go ahead and, as I was saying before, just graph this line y is equal to 1 million. This is my preferred method of using your grade 11 function skills to solve this in Desmos, is you just go in there and you find that intersection, and it tells you, well, it takes 76.76 years. There's his money, and this is the situation, right? Now, supposing you want to do guess and check, did you notice that I was having fun using my calculator, but you might not have fun doing your calculator that way? You can actually do the guess and check in Desmos here. Watch this. So you say, well, I know I want 2 raised to the power x over 7, and I want that to be equal to, and so I can just go down here. Let's just make this t, and we'll put in a slider, and I'll do my guess and checking here. Watch this, 76. Oh, I'm pretty close. I want this to be 2000. 76.7. Oh, I'm closer. 7. Oh, no, that's too big. 6. Oh, that's too small. 1. Oh, that's too big. Oh, 5. Well, that's pretty good. Can I get closer? 4. 9. Okay. 4, 8. 5. No. 9. No. 8. 6. No. 7. No. 8. No. 9. No. 10. No. Okay. 4, 8, 9. Yeah, it looks pretty darn good, doesn't it? I mean, we're pretty very accurate there. Let's go 0.4899999. Okay, there. See how fast I can refine my guess and checking? How accurate do you want it? Okay, I can get it really accurate really quick. So, that's, I challenge you to find a better value. Okay, so if you use logs, or you use your grade 12 method, or you use photo math, you're not going to get it that exact as I can get it with guess and check. Some students think guess and check is like fumbling around in the dark. No, I'm not. You see, I'm not fumbling around in the dark here. I know my tools, and I also know how to rearrange the equation to make solving this the easiest it can possibly be, to a very high degree of accuracy. So I know that it will take 76.76048999265 years approximately. That must be to the nearest millisecond. I mean, that's really close. So this is how you solve these types of things. This is how graphs, tables, and equations work together to structure your way of approaching a solution and support your learning throughout. I hope that this video finds you well. If you got to this point in the video, I salute you. And the code word that you can email me is Dizzy Hippopotamus. Email me the code word Dizzy Hippopotamus, and I know you've shown up for your learning. Bye for now, everyone.